Hi, we'll be taking up today a session on real numbers. I'm just let me just write down. First on the real numbers, I think in the CBSE textbook you have this includes division lemma. Let me explain that. I'll just write the lemma. The lemma says it is A is equal to, I'll tell you what does this A, B, Q and R they represent. So suppose there are two numbers A and B where A is greater than B. So A can be represented as BQ plus R, where R is the remainder. I can give you a small example, as this representation is actually related to what you have simply learned in division. What we do is, suppose I'm writing suppose 36 and 9. This is suppose A and B. How do you divide it? You write it as 36 9 and that gives you 4 and this becomes your 0. So you have got a remainder 0. You got a question that is 4. How do you represent 36? You write 4 into 9 plus remainder, that gives you 36. The same thing is being represented here. Your A, that is the bigger number, that is 36, can be written in terms of B, that is 9 into 4. In that case, the remainder here is 0. You might get a remainder which is 1, 2 or so on. But there is a condition which restricts remainder. Obviously, the remainder cannot be more than the dividend here. So, the condition here in the lemma will actually be written as R should be greater than or equal to 0, or it has to be less than B. Okay, so I mean in the case which I had taken the example, it cannot be more than 9. It is as simple as your division. So A is equal to BQ plus R, where R should be greater than equal to 0 and less than B. And this is called the division lemma by Euclid. Now I'll take up few questions which is given in your textbook, CBSE textbook. Let me clear this part so that I can use them for solving the question. I'll just write down the first one here. First one says, show that any positive integer is of form 3q, where is 3q, or it can be 3q plus 1, or it can be 3q plus 2 for some integer q. How do we do it? Let me just I reduced the font. It's okay. Yeah. To solve this, let me just assume let A be the positive integer. I'll just use some short forms. Let A be the positive integer, and as because it says it is in the form of 3 cube and so I'll take B as 3. Now what does the division lemma says, wherein I have taken A as any positive integer and B to be 3. So A can be written in terms of B. So it will be anything BQ plus R depending upon what your A is. So this R should be greater than or equal to 0, or it has to be less than 3 because 3 is B. Look at the condition here. It has to be less than 3. This is the first condition. So what can be the possible values of R? It can either be 3q plus 0, where R is nil, or it can be of the format 3q plus 1, or it can be 3q plus 2. In all the cases, B remains 3. So this is how we can prove that any positive integer can be of the form 3q. If it is 3q plus 0, that is actually equivalent to 3q, or it can be 3q plus 1 or 3q plus 2. This is the first question I can take. Next I move on with another question. I write it up here. It says, show that any positive odd integer is of the form, where can I take 4q plus 1, or it can be 4q plus 3, where q is some integer. This is similar to the previous question which I had discussed, but here it has to be in the format of 4q, and the a is to be any positive odd number. So a, let us assume to be any odd positive integer. And b will be 4, as it is given to be in the format of bq plus 1. What does the division lemma say? Again we write it. A can be written in the form of bq plus r. So a in this case will be equal to 4q plus r, and here the r's should be greater than equal to 0 or less than 4. So the possible values can be expressed as a is equal to 4q plus 0, that is 4q. So a is equal to 4q. The second possibility, 4q plus 1, or it can be 4q plus 2 or 4q plus 3, because r was between 0 and 3. Now a is an odd integer, so it cannot be equal to 4. Any number divisible by 4 means it is divisible by 2, so that doesn't, this option is not available anymore, because this is not giving us odd number. Similarly, 4q plus 2 will also be not available, because it is then divisible by 2. Rather, these two setups, that is 4q plus 1 and 4q plus 3, they are both in the form 4q plus 1 and 4q plus 3 will represent any positive odd integer. This is not as difficult. We can take another example maybe. Okay, I can move on to another screen and write down the question first. Show that the square of any positive integer is of form 3m or 3m plus 1 for some integer maybe m. Again I will assume here the a to be any positive integer, and we have to show any positive integer. If you recall, we just I think did it in the first screen, to be of the format, any positive integer is of the format 3q plus 1 or 3q plus 2. I'll write the same thing there. It is in the format of 3q or 3q plus 1 or 3q plus 2. So we have the cases where I'll take the first one, where a is equal to 3q. We have to find square, so it is a square. In our case on the right it becomes 3q square, that is actually 9q square. we have to show this in the format of 3m, where m is any integer. So I can break this up and write 3m. If I write 3 into 3q, so it is 3q into 3q, where this is equal to, then this is m, this is equal to 3m, where sorry m is equal to 3q, right? Now the second option available is again a square. In this case I am taking it is 3q plus 1 whole square. If I remove and open it, I get 9q square plus 6q plus 1. Again I take 3q common. The first one I will be left with a 9q. Here I will be left with a 2. And then 1 is left. Oh god. So again I am getting this as 3m plus 1, where in the second case I am talking about m represents this q. Oh god, q, 3q plus 2. I hope I fit in there. Okay. And in the third one, this is 3q plus 2 whole square. So it is 9q square plus 6 2, this is giving me 12q plus 4. This I write because I have to express it in the format of 3m plus 1. So I'll write it as 9q square plus 12q plus 3 plus 1. That can be left out. And what can I take common? If out of all this I can only take 3 common, so I'll be left with a 3q square plus 4q plus 1, and then outside this is 1. In this case, this whole thing becomes m, because m can be of some integer. So when you represent that, it has to be, and try to make it or give it in the format where 3 is there, m is one number, and there is either plus 1 or it is only 3m. Oh, I made a mistake, I think here. The first one I made a mistake. It will be 3m in the sense this will be then 3q square. So it is in the format 3m. Second, it is right. The third one here, if I write it as 3m plus 1, you need to write m here is 3q plus 4q plus 1. There will not be very difficult question on this. You just have to stick to the format of lemma and try to express all of them in 3q plus r format. BQ plus r format, and take the remainders as in relation to b. And in such questions, just stick to what they want you to prove it. When it says some integer m can be any integer in all the 3 steps. I hope you got this lemma part. In the next session, we will see the algorithm and how that can be applied to find the HCF of any given numbers. Thank you.